Hello everyone. Rather than writing a long and arduous document about how to actually use this app, I thought it'd be best to just make a video. It's quicker, it's easier, so hopefully this won't take too long. So yes, version 2 of the Linux Auditd app is now available. It's a big improvement from version 1, so we're going to go through a few things quickly. Most importantly, read the documentation first. It's here in GitHub. If we go down here, all the details are there. It's definitely a good idea to read the About page first. It talks about what Auditd is, how it works, and how you can get the most out of it, because it has a lot of potential there, and with very little configuration you can do a lot more than what it does out of the box. The release notes, generally pretty boring, but it covers what's new in this particular release. And then the installation configuration guide, which of course is most important. There's nothing too remarkable here. Basically, you install the app, copy the TA out of it, and you're pretty much ready to go. There's nothing of note there. Obviously the data has to be source typed correctly, and if not, it's not going to work. So there's a few caveats there and it talks about that. And then how to configure the lookups. Again, there's nothing particularly remarkable there. The only thing I would stress is that the app uses pivot quite substantially in a number of dashboards. So if you can enable data model acceleration, it will definitely improve the performance of certain dashboards. Okay, so let's jump into the app. Here we are. Okay, so with version 2 we have the new Security Operations Center dashboard, and the idea behind this is that there was 3, maybe 4 things that I would typically look for in the version 1 dashboards, things that I was concerned about. And rather than having to do that manually, I figured it would be better to have Splunk do that programmatically and just let me know if something's wrong. So the things here are the number of hosts. Is it stable? Is it increasing? Is it decreasing? The volume of events, and we'll get into that in a minute because that's actually quite difficult to do in different environments, or to detect anomalies for reliably. And the access vector anomalies is to do with SE-Linux, and that's not just every AVC. This is actually detecting AVCs which are anomalous. I'll talk more about that in a moment. And then severe events. So Auditd has quite a variety of types of messages that it can log, and the TA automatically assigns a severity to each of those, and anything that's high or critical will then come up in this list. So we can see a blip here, so this event occurred. So importantly, whatever's below each of these indicators is what you can actually see in the graph here. So there's three blips above there. One's very small, and there's one notable event happened here, and again one here. So if we work through these, the number of hosts, basically the app automatically detects the hosts in your environment, and if they, for one reason or another, are no longer sending data, they will then appear in this list. Now, if you decommission a host, obviously it's going to suddenly appear in this list. So you need to, it will come up there and it will say the host is missing. In order to get rid of that, you need to add it to the decommission host list, and we'll have a look at that in a moment. Now, with the anomalous event volume, let's open this in search, and we'll break it down quickly of how it actually does this. We create a count of the Auditd events with a 1 hour time span back 72 hours. Then we use Splunk's prediction command on the historical data, so the future time span is 0. And if we just run that, you'll see what this looks like. Okay, so you can see in blue there's the count, and then in yellow is the prediction. So clearly that count was significantly above the prediction, as was this one here. So this is quite interesting, and that would be, if we go back to here, that would be the 9.9. So that's really important. With these three indicators here, anything that is above 0 is bad, essentially. So as soon as it gets to 1, that's something that you want to pay attention to. So any difference that's greater than 1 or less than -1 will appear in this list. And essentially anything that's greater than 1 you really want to pay attention to. And the reason being is that if we come back here and we look at the rest of this search, it calculates the range between the upper and lower bound here of the yellow range, and then determines the difference. So I won't go through each part of that, but essentially if we take that range there, the size of that range, the magnitude of that range, and then a little bit like standard deviation, add it to the top, calculate how far this count is above the top of the yellow range or below the bottom of the yellow range, depending on whether it's above or below, then we've got a magnitude by which we can get an indication. So within the span of the yellow, we essentially have 0. So it's within permissible limits, you might say. But anything outside of the yellow range we want to be aware of, and particularly, for example, this one here would be 9 times the range, the yellow range, or above, 9 times the yellow range above the yellow range. So it's quite clearly anomalous. We search the difference just to remove the things that we're not interested in, and then we just create a table of them. And that is done for the single value field. Anyway, not important. Essentially, all of these drill down as well. There's nothing particularly remarkable about this drill down. You can already see from here that there's an anomalous event count. Let's have a quick look at it though. Okay, so here it is there. So something clearly happened at that time. If we come down here, user, okay, so that was me. So that would have been last night when I was publishing this app, presumably, because nothing else happens on this server in the meantime. Something else to note, each of these is using accelerated data models, back 72 hours. This one's 7 days, but these three are 72 hours. And this is a single core machine, so it's very, very fast. If you don't enable data model acceleration, they will work perfectly fine. They'll just be a great deal slower. If we drill down on this, so we can have a look at the search that actually underpins this. Oh, actually, no, we can't. Sorry, excuse me. I will jump back here and open this. So I'll open the search that populates this field here first, and we'll have a look at this. Okay, so we're pivoting on the Auditd model, which is provided by the TA, and we get the values of the types, and we essentially split it by the hour, and then we expand the types out for each of the domains. And then we want a count of those to determine when a domain accesses types that it hasn't previously in the last 72 hours. So typically if SE Linux is poorly configured or incorrectly configured, I should say, it will spew out ABCs constantly, or at least it will do it at a rate at which this simply won't trigger. The point of this is that this will detect things that are weird, that are anomalous, that you really care about, not the noise that's being generated. So you could have a fleet of 2,000 RHEL machines producing, thousands of ABCs an hour each, and this should not, by design, trigger. It's there to detect compromise. So it's there to detect when a domain, that is a process, is accessing stuff that it wouldn't normally do. Yeah, and that's obviously using the eval within the count here as the indicator. Okay, so I've configured a custom drill down here, so when we tap on that, it doesn't drill down to the same pivot because that's not very useful. It drills down to this macro here, and this comes from version 1 actually. So the ABC table is really good. This star here is, we don't know which host it came from, but you can put a host in there, and then this is the domain. So in this case, it's drilled down to demo t, and then it searched for the type user home t, and we can see exactly what happened. So at this time, on this host, this user, and remember this is the actual user, this is not the effective UID or the UID, this is the actual UID, so the person that actually logged into the machine. So irrespective of whether or not they use sudo, or whatever, this is the actual account that caused this event. The command that they ran, the domain, the type, the class, the permission, the object, whether or not SE Linux allowed it or not, because again, we are not so interested in whether or not SE Linux by policy is allowing it or not, because things which we explicitly log and allow in SE Linux, we also are concerned about with audit allow rules. So we don't filter on that. And if the underlying system call was successful or not. So in this case, it was not. So SE Linux and that domain are clearly not impermissive. So we can see what's actually happened. Really, really good drill down. Okay, so let's jump back to the SOC page. And again, so the severe events, there's nothing really remarkable about this. This is actually pretty bog standard stuff. Basically, it pivots on the same data model and then just does a count by critical and high and then charts it for us. So you should be seeing zeros. If you're seeing anything but zeros here, be concerned. In this case, I've deliberately caused a severe event to happen. I've turned SE Linux off. And as per Dan Walsh, this is a bad thing. And I immediately turned it back on. So if we come over here, we can see that it actually knows that I did that. Right? It doesn't say root did that, it says the user Doug did that. So the max status was changed, enforcing was 1, and the old enforcing was 0. So I turned it off and turned it immediately back on again. Let's go and have a look at the user TTY to have a dig into that. So if I look for the user Doug in the last 24 hours, the user TTY logging is keystroke logging, and that might make you uncomfortable, but it is very useful. And if we jump down here, we will find, let's do the last 7 days. This server's in a different time zone, so I don't actually know what time it was that I did this. So you can see all the commands that I've run in the last 7 days, and there it is. So at that time on this host, I ran with this session, so this login session as root, I ran set enforce 0, semicolon set enforce 1. So it's turned SE Linux off and turned it back on, or permissive and enforcing all at once, which caused those two severe events that came up on the SOC dashboard. we'll quickly cover off, regarding the user TTY, look in the documentation, there's more information about that, how to use that. You have to configure it. It's not something that Auditd does by default, but it's very easy to configure in one line, and it's very, very useful. This is the kernel dashboard. There's nothing particularly remarkable about this. I'll just cover it off. Yeah, it's very useful for digging down into events and determining what has actually happened and who did it, because obviously you can look across these and you can say, well, these successful events are user events, and these are the types of events that occurred, and they were low and 4 were medium severity. So yeah, it's a great dashboard. System call, basically the same thing. The only thing to say of note with this particular dashboard is that at the bottom is this. And this is particularly useful because it's actually correlating the system call events for you. So when you configure, and as per the documentation, please read it on how to do this, when you configure file system auditing on a path, and you say, I want to audit all rights and attribute changes, for example, on this particular path, whenever that happens, Auditd will actually log several messages, or several events, I should say, with different types, and you need to correlate those together in order to get the full picture. This part of the dashboard is automatically doing that for you. So it's giving you current working directory, the session, the command that was run, pardon me, the name of the file that was being the system call was against, the system call itself, and whether or not it was successful. So really, really useful stuff. Type enforcement, again, this is SE Linux. You can use Auditd without SE Linux. I would strongly recommend against it. At least put SE Linux in permissive. Please see the documentation for more of my rant on that. We'll quickly have a look at this. There's nothing to remark, which is kind of good. Let's go back a little bit further. So let's go back 48 hours. Because I did actually cause an AVC. Yeah, there we go. Great. So that was the AVC that we saw in the SOC dashboard. So there's 12 instances of them. And again, at the bottom here we have correlated events. Exactly the same as the system call dashboard. It's correlating multiple events and then giving you a nice little summary here. Very much like the AVC table macro that you saw earlier. Really useful. And the sudo dashboard is new in version 2. So Auditd actually logs sudo commands, and it's almost as useful, or it's almost the same fidelity as the sudo log itself. I would still recommend ingesting the sudo logs and using the ta_sudo app from Splunk base that I wrote as well. But this is still really useful. If we run this back 7 days, it's pretty good. In fact, it does give a little bit more detail in different ways. So again, the actual user was Doug, the current working directory, and the command that was run, and whether or not it was successful. The only thing that I can see that it doesn't have is the user, the destination user. So yeah, still very useful. And the host dashboard is new in version 2 as well. So version 2 automatically learns about your Auditd hosts in your fleet and will populate this, this drop down. And again, it automatically determines the operating system and the kernel, the architecture, the IP address of the machine, and it has a reasonable guess at the uptime. So it's able to determine the last boot, and from that we make a rough estimate of the uptime. in practice, it's actually very accurate. It's a good indication, particularly if you're not familiar with the machine that you've selected up here. It's a good indication of, in addition to who's actually logging into the machine and whether or not processes are crashing, what might be related or the symptoms and causes of a problem. And down the bottom here, we just have a time chart of events by severity for that machine. So we can see a spike in informational events here. Not really concerning. Okay, and here we have the reports. There's only 2 reports in the current version. There's the Linux login report. So obviously Auditd logs authentication authorization, and this just gives you a nice little summary of it. And the Linux process crash. Now this machine is just a tiny little VM out in Linode, so nothing particularly remarkable has ever happened to it, but there are 2 crashes back in time somewhere. So here we can see this host, this process, through this signal. This is the description of the signal instead of reading that one, and the number of them. So in a production environment, and it's sorted by the count. So in a production environment, you might have thousands of Auditd hosts, and you might have all sorts of crashes going on, and you want to know about them. And this report is a good template, if you like, for creating your own reports to determine problems in your environment like this. Okay, so the help dashboard. So there's a link to the wiki here, and this TA status should always stay working. If you haven't upgraded the TA, it will let you know that you haven't upgraded the TA in this search environment. Or if you haven't installed the TA at all, this app obviously is not going to work, and it will tell you that. Very importantly, as per the documentation, you have to tell it about local POSIX users and directory POSIX users. And there's a little mark here because I haven't actually done that in this instance. But basically, it also learns POSIX users when you configure it initially, and it will add these together, or it will merge them, I should say, and resolve any UID conflicts into this one here. And if there are any UID conflicts, you'll see them down here, and that is basically where you've got more than one username assigned to a UID. So you might have in the past created a local user account on a machine with a certain UID inadvertently, and then now you're using the directory for authentication, but a different user has that UID. So in that instance, the Auditd app doesn't know what to do, so it will list the UID conflicts there for you to resolve somehow, but in the interim, what it will do is it will just give whenever it populates the user field, it will just populate it with the UID instead of the username, because it doesn't know which username to actually use. And finally, the indices that it actually found Auditd events in, which is really cool. One of the things that this version actually does is it automatically figures out where your events are and who your users are, what machines you have in your environment, and it automatically just configures itself. It's very cool. And this is the configure dashboard, which you just simply run like this the first time you install the app. You only need to do it once, and it just populates all of the lookups. You don't really need to look at it. It's no big deal. And yeah, but of course, please make sure to read the actual installation and configuration guide, because it goes through step by step how to actually do that. I think that's all for now. The only other thing that I wanted to mention was the decommission hosts. So if we jump in here and oops, let's see, apps, lookups, decommission hosts. Okay, so if we were to actually, before I do that, I'll modify the actually no, I won't. Yeah, we'll modify the decommission host. Okay, so we can put a host in here, so foo.com. Now, then that would prevent foo from coming up here, but my recommendation would be to use the lookup editor. So this is a really useful app. The Auditd decommission host is here, and there's foo.com. So we want to remove that, save the lookup. And if we come back here, there we go. Yeah, brilliant. So yeah, obviously you need to add decommission hosts to that list. You could do that programmatically by some means. If in your decommissioning workflow you have some way of doing that, that would be good. If not, you could run a Splunk search that somehow determines that a host has been decommissioned and then pipe that to an output lookup with append. Yeah, there are a number of ways to do that. I might make some more discussion about that in the wiki in the future. So I hope this has been helpful, and please let me know if there's any features that you'd like to see in upcoming versions, any bugs, anything at all that you'd like to know. Just let me, just give me a bell on GitHub or on answers.splunk.com. Thanks. Bye.